Okay. So now we just want to find the area bounded by the parabola, which is y is equal to x square plus 1 and the straight line x plus y is equal to 3. So y is equal to x square plus 1. We have this equation for the parabola. X square is equal to 4ay. And this equation shows the parabola is symmetrical above the y-axis, which means you will have a diagram like this. Parabola is symmetrical above the y-axis. Okay. So here you do have y is equal to x square plus 1. So you can rewrite this as y minus 1 is equal to x square. Can you do the diagram? Can you do the graph part for the line equation and the parabola equation? The line equation is given as x plus y is equal to. I'll give you a shortcut. Like rather than substituting random values and finding the graphs individually, you can just equate the curve, which is parabola, and the line equation. Okay, just equate them. If you equate, you will be getting x square plus 1 is equal to 3 minus 6. You will get a quadratic equation. It's x square plus 1 minus 3 plus 6. That would give you x square plus x minus 2 is equal to 0. You just have to solve the quadratic equation. And what are the factors if you solve them?
One.
One and it's plus 2 and minus 1, right? Isn't it?
Yes, ma'am.
Times of minus 1 will give you minus 2, which is the product of the factor. And 2 minus 1 will give you the coefficient as 1, which is sum of the factor, right? So you'll be getting x is equal to minus 2 and x is equal to plus 1. So that would be maybe here and over here, right? So substitute these value in the y equation, we'll be getting the values of the y coordinates as well. If you substitute x is equal to minus 2 in the y, it's going to be 3 minus of minus 2, which will give you 5. So you're getting minus 2 comma 5. And substitute 1 there. It's going to be y equal to 3 minus 1, which is 2. So that would be like 1 comma 2. So it's minus 2 comma 5 and 1 comma 2. Minus 2 comma 5 means like 1, 2, 3, 4, 5 maybe over here. And 1 comma 2 means maybe over here.
Okay, ma'am.
So the equation is x square plus 1. Y is equal to x square plus 1. Y is equal to x square means you will draw the parabola like this, right? It will maintain a contact over the origin. Plus 1 means you just have to shift one value. So the parabola will go like this, right? And the line will pass through these 2 points, these 2 coordinates, isn't it? So this is y is equal to x square plus 1. And this must be y is equal to 3 minus 6. Is it clear?
Yes, ma'am. Clear.
So now we're just going to find the area bounded by the curve on the line, which is this part, by using the integration. So I told you, you have to equate the equation 1 and equation 2. You have to equate the curve on the line. By equating them, you're not only finding the intersection point, you will also find the starting limit and the final limit. Okay. Here, the starting limit is -2. The final limit is +1. Okay. Shall I erase them? Did you copy?
Ma'am, can you explain how we got that parabolic form once again?
Parabolic curve.
Yeah, parabolic curve, yeah.
Okay. So the given equation is y is equal to x square plus 1, right? How do you draw this? How do you draw this in mathematics? Like if I say y is equal to x means it's 1, 1, 2, 2, both are same, right? So y is equal to x square plus 1 means, like, how do you draw them? You have to substitute some random values for x. Maybe like 2, 1, 2, and also the values which you found. The -2 also you can substitute, -1 also you can substitute. Substitute here, it's going to be, if you substitute 0, it's going to be 1, y is going to be 1. 1 square plus 1 would be 2. 2 square plus 1 would be 5. -2 the whole square plus 1 would be 5. -1 square plus 1 would be 2. Do you follow?
Yeah.
So these are the coordinates. So these are the coordinates, right? So bottom in the graph, it's just going to be like 1.
Now we just join that coordinates.
Yeah.
Okay.
Make sure you're substituting 0 and you're getting 2 points, right? By equating the curve on the straight line, that you can substitute. For getting an exact curve, you can substitute 2 more values. Like 4 or 5 values, 4 or 5 coordinates are enough for getting the exact diagram. Okay. So 0, 1 may be here, 1, 2 over here, -2, 5 may be here, -1, 2 will be here. Like if you just, you just have to join all of them. You understand? Here, it looks very ugly over here. You just have to connect it like a parallel. I'm not able to draw. This is it clear?
Yes, ma'am, clear.
Do you understand the straight line which I drawn? The x plus y is equal to 3. Did you understand that part?
Yes, ma'am.
That can also be fine by using the same strategy. You just have to write x plus y is equal to 3 as y is equal to 3 minus x. Substitute some values for the x. You'll be getting y coordinates. Is it clear?
Yes, ma'am, clear.
Yeah. So the starting limit is -2, final limit is 1. Okay. So when you write this, you're getting a diagram like this, right? So when you do integration, you always have to write above minus below if you are integrating with respect to x, because we were getting the quadratic equation in the form of x, isn't it? It was x square plus x minus 2, right? It was x square plus x minus 2. This was our quadratic equation, right? So if you're getting the quadratic equation in the form of x, you also have to write the limits in the form of x, because you are factorizing the quadratic equation which is in the form of x only. You have to write the above function minus below function. Above means you just check them, like this seems to be above the line, and then curve lies underneath that. So that would be like -1 to 2, the line equation minus curve equation, and you're integrating with respect to x. So it's -2 to 1. Line is, what is line? Line is x plus y is equal to 3. You have to write them in the form of y. So y is equal to 3 minus x, because you are integrating with respect to x, right? So you will be writing 3 minus x for the line equation and the curve equation. What is curve? Curve is the below one. Curve is x square plus 1. So x square plus 1 dx. Subtract them. -2 to +1. and 3 minus x square minus 1 dx. So that will give you minus 2 plus 1, 3 minus x, x 2, 2 minus x square into dx. So just integrate them and substitute upper limit minus lower limit. I taught you that second fundamental theorem of integration. You remember? We just have to substitute their limits, the upper limit and minus lower limit after the integration. And once you're done with the integration, you have to remove the integration sign. Okay. Can you do this and tell me what you're getting as the answer? The answer should be done with the square units because we are finding the area here.
Okay. Completed. 9/2 square.
What you're getting?
9/2 square units.
Yeah. 9 by 2 square units. Good. Okay. Okay, let's see illustration 31. Find the area bounded by y is equal to x cube minus x and y is equal to x square plus x. Okay. This is a bit tricky because y is equal to x cube means it's just a cubic equation. So we will draw a cube curve like this, right? So x square means we just have to draw like this, right? That is y is equal to x square. But here you have to subtract the line x from that, and here you have to add the line x with the parabolic curve, right? So let's see
Yeah.
how to depict them. So it's x cube minus x. In general, okay, let me use the straight line. Let me go with the parabola first. Like this is the diagram, like the extremum of the parabola will pass through the origin if y is equal to x squared. Like when it is plus x, the coefficient of x is 1, right? So you just have to shift one value in the left side. It becomes the extremum will pass through this point. Okay, it will pass through this point. So this is the equation for y is equal to x square plus x. I'll teach you like how to find the extremum also. So I was talking about the extremum. Actually, very recently I was doing this kind of question. So I will show you. There is a general form of a quadratic equation, right? Like which is ax square plus bx plus c is equal to 0. This is the general form of the quadratic equation, right? And here your equation, the quadratic equation is uh, y is equal to x square plus x. So it's x square plus x. If you factorize this, let's equate this to 0. If you take x outside, it's going to be like x plus 1 is equal to 0. So x is equal to 0 and x plus 1 is equal to 0 and x is equal to minus 1. Just a second. x is 0 and x is minus 1 here. Do you follow this?
Yes, ma'am. Yes, ma'am.
Actually, you have to follow this general equation. The actual equation for the quadratic equation is a times x minus h the whole square plus k. Okay. So here we have the coefficients as 1 luckily. So you are able to get the answer straight away. But in general, what if you have the equation as 5x square minus 30x plus 49 like that? So in that equation, you have to use these things. You have to rewrite the quadratic equation as a times x minus h the whole square plus k. So that would give you need a, right? So there is no constant is k. So the k is absolutely going to be 0. And if you take the a, what is it? A is coefficient of x square, right? So that's going to be like 1 times x square plus x1. So here, if you notice, you have x minus h the whole square. But here it is x square plus x, which is in the form of a square plus 2ab. That can be written as a plus b the whole square minus b square. Okay. So that would be x square plus x, which means the value of a is x here. And how do you find b? 2b is equal to 1. So b is 1 by 2. 1 by 2 the whole square and 1 by 4. So this is going to be here. You have to place this over here. So that will give you the a times a is 1 only, x minus h. So it's x plus 1 by 2. I said minus, right? So you have to write this as minus of minus 1 by 2 the whole square plus we have minus 1 by 4 here. So minus 1 by 4 plus 0. So now this looks like x minus h the whole square plus k. So this is going to be a vertex. H comma k is going to be the vertex. Minus 1 by 2 comma minus 1 by 4 is h comma k. Please copy.
Yes, ma'am. I've copied. I'm done.
Copied. I'll give you one more. How do you find minus x squared plus 10x plus 5? Okay, this is the quadratic equation. For this kind of equation also, I've told you it's a times x minus h the whole square plus k. That is the common form of this. So that if you write, it's going to be the coefficient is 1 here. So just 1 times minus x square plus 10x plus 5. You have whole square format here. So it's minus x square plus 10x. So if you use this a square plus 2ab is equal to a minus bd whole square minus b square, I mean a plus b whole square minus b square, that will give you, okay, you take minus outside, okay, we'll assume a as minus 1. Let's change this into positive x square and minus 10x, okay. Then it would be a square minus 2ab. A square minus 2ab is equal to a minus b whole square minus b square. So that would give you x minus 5 the whole square and minus 5 square. So it's minus 1 times x minus 5 the whole square minus 5 square is 25 plus 1. So here you're going to have minus 20, x minus 5 the whole square, a is minus 1. The vertex is h comma k, so that would give you 5 and 20. Is this clear?
Yes, ma'am. Yes.
I'll give you one question as homework. You find the extreme value for that.
Okay.
Please copy it. I'll give you one more.
One. Completed, ma'am.
One second here.
Okay.
Okay. Please copy this question. This is for the homework. Find the extreme value of this.
Okay, ma'am.
Shall I erase it?
Okay. Okay. Yeah.
So I told you the equation is y is equal to x square plus x. I told we have got x as -1 and 0. Remember? So the -1 and 0 are the intersection points. Do you remember the extremums? We got -1/2 and 1/4, I guess.
Yeah, and then
What
5
was h
and
comma
minus
k?
12.
I'll zoom the graph further. Let's break them into 0. Like 0.25 like that. So let's have -1 here, -2 here, 0 here, and in the y-axis -1, -2. What was h comma k?
Minus 1/2 and minus 1/4.
1/4. So minus, and what was the intersection point? The x values are 0 and -1, right? I
Yeah.
mean, it's not x comma y. The x values are 0 and -1, which means it will pass through, the parabola will pass through here, right? And -1/2 and -1/4. So -1/2 -1/4 means h is the x coordinate, k is the y coordinate. Maybe -1/4, -1/2, -3/2, and -1. Maybe -1/4, and here like -1/2, which is -0.5. Maybe over here. Okay, so that's going to be our extremum, right? So your parabola will pass through this, and this is going to be the extremum point. In the exam, they won't ask you to find this extremum. I'm just teaching you. Like, you don't have to find what is h comma k. You just have to find what is 0 and -1. But if you knew the extremum point of the curve, it would be very easy for you to finish the graph. Okay. You can find out the exact area, exact trap region, and it's really useful. Like in the I think in the 6th chapter also we do have, right, finding the absolute maximum, absolute minimum in the limits. So that would be helpful in that chapter as well. You can use this method also over there, because in the JEE exam you are only going to show your answer. So without doing the differentiation, you can also use this method for that. All right.
Okay.
So I hope you are aware of this one. Y is equal to x squared plus x is going to be the answer for this curve, and y is equal to x cube minus x. So y is equal to x cube minus x. You do have two equations. Y is equal to x squared plus x. Y is equal to x cube minus x. So you can equate them for finding the intersection point. So that would be like x cube minus x is equal to x square plus x. So that would give you x cube minus x square minus 2x is equal to 0. Can you factorize this cubic equation and tell me what you're getting as the factors?
Yeah, yes, Aman. Ma'am, 0, -1, and +2. Ma'am, 0, -1, and +2.
Did you solve?
Yeah, yes, ma'am. 0, -1 and +2.
Sorry,
0, -1, +2.
0 minus 1
+2.
plus 1 now.
+2, ma'am.
Plus 2. Are you sure it's plus 2?
8
Can you check?
minus.
Because like I'm getting something near to 6, somewhere near 6 I'm getting. Can you check? Like 0
Ma'am,
is
if we
correct.
substitute +2 there, then we are
0
getting
is
0.
correct. Minus 1 is also correct. Only the third value is bothering.
Oh,
I think you are right.
yeah, when we substitute +2 there, then we are getting 0, ma'am.
Yeah, you're right on it. Minus 1 and 0. Like which means the cubic equation will pass through. This is minus 1, right? Like,
Yeah, yes, ma'am.
and 0 maybe like this. Is it clear?
Yes, ma'am. Clear.
So now if you focus on the shaded region, these are all going to be a shaded, I mean bounded region. These are the bounded region. Clear? So now we want to integrate this. How? You have, if you are integrating with respect to x-axis, it's -1 to 0. Okay, you can split them actually. You can split them into two parts, -1 to 0 and 0 to